All right, I think they've leveled off a bit, and I want to make sure there's plenty of time for the presentation today. So I want to thank everyone for joining today's webinar. We're excited to talk with you all about how aluminum beverage cans are a key driver of the U.S. recycling system and how we can capture even more revenue from used beverage cans, UBCs, by capturing missorted cans at the material recovery facilities, or MRF, which is where single-stream recyclables are sorted out. So you'll be hearing UBC, used beverage can, and MRF, material recovery facility, quite a bit in this webinar, so keep those acronyms in mind. I'm Scott Breen. I'm Vice President of Sustainability at the Can Manufacturers Institute. So that's CMI. CMI is a national trade association of the U.S. metal can manufacturing industry and its suppliers. CMI's members annually manufacture approximately 120 billion food, beverage, and general line cans, all made of metal, aluminum, or steel that recycles forever. So CMI organized this webinar, and we've got 6 knowledgeable, engaging speakers lined up for you, and they represent many perspectives in the recycling system, and 2 of them can actually give firsthand accounts of how they operate their recycling operations to capture many more used beverage cans. Okay, so I'm realizing I'm not sharing my screen with you all, so hold on a second. I'll pull that up. All right, sharing my screen. It's not showing. Hold on one second, everybody. All right, here it is. Okay, so the speakers that we have for you all, we'll start with myself and then Corinne Rico, who's project manager at Gershman, Brickner, and Bratton. We're going to explain the beverage can's existing circular system and the findings of GBB's recent report that found how much revenue in the recycling system comes from cans, how many cans are missorted, and how we can capture those missorted cans. Then we're going to turn it over to Jeff Lacey, Senior Staff Scientist at the Idaho National Laboratory that's within the U.S. Department of Energy. And he's going to talk about their work that's looking at the value of aluminum and aluminum beverage cans and some of the technology that's out there to capture beverage cans at these material recovery facilities. Then we're going to hear from those firsthand operators of recycling operations. So John Hansen, he is co-owner of Single Stream Recyclers. He will discuss his experience at his company's MRF in Sarasota, Florida, that has robots that quality control for those UBCs, used beverage cans. And then we'll go to Kate Davenport, who's co-president of Eureka Recycling. She will discuss Eureka's experience with 2 eddy currents at its Minnesota MRF. And then to take us home will be John Powell, Vice President of Closed Loop Partners. And he will be discussing how investors view aluminum can capture equipment and ways that we can get more of this equipment in MRFs. So we hope to have at least 10 to 15 minutes for Q&A after all the speakers have made their short presentations. Some housekeeping notes before we get into it. If you have any questions for the speakers, as I'm speaking or the other people are speaking, please type them into the Q&A box. You should see at the bottom of your screen, it says Q&A, you just pull that up, type it in. You do have the option to submit your questions anonymously if you'd like. And then the speakers will either type answers into that Q&A box or we'll note that we're going to answer it live during the webinar. We'll do our best to touch on all of them. And you should note also the chat is disabled. If you're having technical issues, please send an email to info@cancentral.com and we'll get you taken care of. And also note that we are recording this webinar and we are going to post it publicly afterwards so everybody can hear the insights that are being shared. So with that, let's get into the presentations and I'll start us off. So I want to talk about first how the aluminum beverage can is the textbook example of the circular economy. It has an existing circular system that takes cans from recycling bin back to store shelf in as little as 60 days. And recycling cans, we do that at scale in the US today with existing infrastructure. In the US, we recycle 120 million cans every day. That's 45 billion cans a year. That 45 billion, that's the equivalent of 12 packs per person every year being recycled. The result is that the beverage can industry has an industry-leading recycling rate of 50% and an industry-leading recycled content of 73%. Now, all of these cans being recycled is beneficial to can makers because they can easily make those used beverage cans into new cans. Those new cans then are made with a relatively low environmental footprint. But also recyclers love when people recycle a lot of cans because of their high economic value. So to talk more about the high economic value of beverage cans and how more revenue can be generated for the US recycling system from beverage cans, I'm going to turn it out now over to Corinne.
Thanks, Scott. Good afternoon, everyone. As Scott mentioned, we worked on the report looking at the economic value of cans. We are a solid waste management consulting firm here at GBB. We work with communities and organizations all over the world, helping them more sustainably prevent, reduce, and manage waste, as well as recover useful resources like aluminum from cans. We work across the spectrum of waste and in multiple sectors, whether that's municipal solid waste, organics, construction demolition, or as in this case, recyclables. And one of the things that helped us in our work for CMI is that we are independent of technology and other private interests, which ensures that we can approach our work objectively using facts to inform our clients' decision-making. So in this case, CMI commissioned our team to conduct a review of the relative value of UBCs in the US recycling program and the MRFs that process these recyclables, and how UBCs can drive the success of these programs further. Our final report, you can find it online on CMI's website. So once you've had a chance to check it out, after I finish going over the highlights that we found, please don't hesitate to reach out to me directly if you have other questions. So for this report, we framed our research around two basic scenarios. We looked at states with container deposit laws and states without container deposit laws. So as a refresher for those of you that live in states without container deposit laws, or bottle bills as they're commonly called, what that means is that states offer a refund on various beverage containers that are returned to redemption centers for recycling. And this incentive has a really big impact on the quantity and type of containers that MRFs receive. The containers received at redemption centers often bypass the MRF for processing. So the share of the containers that MRFs actually do receive, recover, and sell on the market is much lower in bottle bill states than it is in non-bottle bill states. And when we looked at the results of the waste and recycling characterization studies, both that GBB has done for various locations and the other entities have done in both types of states, we found that UBCs made up only 0.4% of the stream in bottle bill states, but they made up 2.2% of the stream in non-bottle bill states. And that might sound small, but when we look at the value of aluminum by weight, it's the most valuable recycling commodity on the market, in the secondary materials market. So what that actually means is that in 2019, UBCs made up 12.5% of potential revenues in bottle bill state MRFs and 33% of potential revenues in non-bottle bill state MRFs, which is more than any other single commodity. Now, it's important to note that I said potential revenues because waste and recycling characterization studies from which we were basing our analysis, they're performed on materials that are coming into the MRF, not those that are going out of the MRF. Along the way, during the process of sorting at the MRF, there are various places where these materials, including UBCs, can get lost and not end up sorted properly with the aluminum stream. Ways they can get lost, there are several. Crushed cans, they can get crushed vertically into what are called pucks, in which case they would be sorted into the fine stream or the residue stream, which is ultimately handled as waste. They can also be crushed horizontally into flat objects, in which case they are sorted like paper. Sometimes recycling facilities will get bagged recyclables, and if the MRF is not equipped with a bag opener, these bags might be disposed with residue. Recycling loads could also be too contaminated for processing. That happens every once in a while. And then MRFs can sometimes have their materials fall off of conveyor belts. So as materials are making their way through the MRFs at various points of transition in the conveyor belts, things can fall off. There haven't been very many studies done to quantify these losses, but the information that we had available at the time of the report we use that to calculate that an average MRF could be losing up to 25% of UBCs at various places in the MRF, meaning that these UBCs then don't end up in the baled aluminum for sale and secondary processing. And that's a lot. If we're talking about a theoretical MRF that processes 50,000 tons per year of recyclables in a non-bottle bill state, that could mean that that MRF is missorting 275 tons of UBCs in a year, or 18.5 million cans. And that's a value of nearly $300,000 in lost revenues, or 8.3% of that MRF's gross revenue stream. It's a lot, 18.5 million cans. So to better sort and more accurately sort these cans, there are a couple of pieces of equipment that are pretty key to this: the eddy current separator and robotics. Eddy current separators are also abbreviated as ECS units. They've been around for quite a while. They're well-established MRF technology. Most modern MRFs already use them, at least one of them. And how they work is that they use conductivity and weight to separate ferrous metals, or metals containing iron, in other words, magnetic metals, from non-ferrous metals, or non-magnetic, like aluminum. Materials pass over a rotating pulley drum at the end of a conveyor belt, and inside this drum there's a motor that has permanent magnets and that create a magnetic field when the drum rotates. The magnetic field then generates electrical currents in non-ferrous metals, which cause them to repel out of the material stream. So they repel outwards, upwards, out of the material stream, and then they're then captured separately from the ferrous metals. So these ECS units, it's very simple, but they have a very effective capture rate. Most manufacturers guarantee at least a 95% capture rate of non-ferrous metals. Robotic sorters are newer. They're not employed yet at many MRFs, although their use is starting to expand rapidly, as some of our speakers are going to talk about today. And they use artificial intelligence and machine learning to visually recognize and separate materials based on which material types they're programmed to target. They're also very effective. And so combined, the effectiveness of both of these can't be understated in terms of capturing these lost cans. When we looked at adding an ECS unit at MRF residue stream, so the material that's already been sorted that is eventually headed towards some kind of disposal, if we were to add an ECS unit on that residue stream, as well as a robot on the fiber or the paper-based line at a MRF, we found that the increased revenue that is gained from capturing more UBCs from these equipment, it could cover the cost of the capital equipment in about 2 years. If we looked at only an ECS unit, the simple payoff of how many more cans you would capture with an additional ECS unit on that residue line, it could pay for that equipment in about a year. So it's a pretty good return on investment. And on that note, I'll turn it back over to Scott.
All right, thanks, Corinne. So to sort of sum up what you all found in your report, if we capture more of these used beverage cans that are being missorted, that means more revenue for MRFs, since cans have such a high value, as you talked about. More cans can be recycled into new cans, since today the vast majority of cans that are recycled get turned into new cans. And it means we'll have a healthier US recycling system overall, because more revenue will be flowing through it. So if anyone on the webinar wants to view the full report, get more information, the website there on your screen, cancentral.com/cansdriverecycling is the place to go. Again, if you have any questions, put in that Q&A box, but we're gonna move on to our next speaker, and that's Jeff Lacey from the US Department of Energy. So I'll stop sharing and then he'll share his screen with his slides.
Thank you, Scott. Let me get my screen shared. All right, am I sharing presentation mode?
You're good.
Okay. Thank you, Scott and the CMI for having us. This is a great opportunity to discuss these opportunities that exist at the MRFs. The Idaho National Laboratory is based in Idaho Falls, Idaho. I work in a research department within there. We have a large material processing facility that we do a lot of our research in. The focus of most of our research in the past has been on biomass feedstocks, where we grind, sort, shred densify these materials to make them more valuable. We've recently begun moving into the area of MSW. That's where our connection here with Can Manufacturers Institute is, where with MSW, you still use the same processes of grinding, shredding, sorting, densifying. We're currently in the middle of a multi-million-dollar upgrade to improve our capabilities for MSW processing. So we'll be adding several of these, some of the technologies that we're going to be talking about today. We will have on hand to begin developing capabilities. So the case of the lost can, where are the cans going? Corinne talked about a lot of these already. 1,260,000 tons of cans are produced every year. We only recycle about half of them in the United States. There are countries around the world that do better than we do, but there are some reasons why these are not getting recovered. One is a curbside desert. I live in Idaho Falls, wide open space out here, and I live in a curbside desert. There was a recycle program here locally where good-natured people could pay to have their recyclables picked up. That was recently canceled. The economics of recycling in general were simply not adequate to support the private company that was working on this. So most of our cans end up in the landfill here. And there is a recycle center locally where I can take my cans to. They'll pay 30 cents per pound. That equates to about 1,000 cans that I need to recycle for about $10, which by the time I save them, have garbage sacks in my garage for weeks on end, drive across town and drop them off, there's not a lot of monetary incentive to do that other than just trying to do the right thing. Another place is unwanted commercial waste. If you see the image on the right hand there, that's obviously at some park or some venue. Recycling doesn't go well at these places. The waste tends to be dirty, and it's more difficult to separate and sort. A lot of MRFs are choosing not to process those types of wastes. The last one that Corinne also referenced was missorting at the MRF, and she did an excellent job of describing where the cans go there. I'll give anybody a guess at what my favorite beverage is. I took these pictures out on my back porch. 25% of these cans are lost, and this is the primary reason why. The cans on the left are good, pristine 3D quality. They're 3D shapes. They sort well in the ballistic shape or ballistic separator, whatever separator you're using to capture your 3D cans or your 3D containers. Once they start to get flattened, either in pancakes or in pucks, it starts to lose its 3D hollow characteristics that make it separate in the ballistic separator. And they end up in the residue line, which is sent to the landfill, or in contaminants in the paper bale. So one, you're paying to throw it away. The other, you're paying in lower quality paper bales. Now, there's 4 technologies here. I'm only going to talk about 3 of them. Manual sorting is certainly one way to get more cans out of your residue stream. My experience, when I have people manually sort things, I lose friends or I lose employees. So it works, and it is something we can do, but it's not effective. Eddy current separator it's a mature technology, but we'll talk about some advancements there. Automated sorting, and these two are kind of connected. The automated sorting with the artificial intelligence added to it, the machine learning aspect actually makes it a much more powerful sorting tool. So eddy current technology usually is put on the end of a conveyor. Inside the last roller on the end of the conveyor, a magnet is placed that is spun at a high velocity or high rotational speed. That creates an eddy current or a magnetic field here on the top of the belt. If you've ever tried to hold 2 magnets together, one way that you put the magnets, they they stick together. If you rotate or if you turn one over, they repel. That's the type of force that's being exerted on the aluminum cans or the other non-ferrous metals that come across the eddy current. So it's going to also has a potential also to eject zinc, nickel, copper, anything else that's not magnetic. Typically, they're installed on a 3D container line. Your plastic bottles and other containers, along with your aluminum cans, are on this line. We're able to eject the aluminum cans out of that. Knowing that aluminum cans, like in the form of pucks or the pancakes, end up on the paper line or the residue line, we could install, and I think there are examples that are going to be talked about later today. They can be installed on those lines to easily collect the material out of there. There's new technology coming out in this. Right now they use actual magnets, and they spin magnets as fast as they can. The challenge is there's only so fast you can spin a magnet physically. There's technology that is being developed that uses an electric magnet. So it's a solid state magnet that uses alternating electrical pulses to generate a much, much stronger magnetic field. This is interesting for perhaps some of these highly densified pucks, pieces of cans, or other scraps of aluminum that might be coming through your residue, especially in your residue line where the fine, small materials are going to be found. Automated sorting on the right here is just a generalized, simplified diagram. They're sensor-based. There are a number of different sensors. The sensor is really the key to getting the right sorter selected. Visible light, I mean, using a high-resolution camera, high-speed camera, lets it see what we see with our eyes. The near-infrared is commonly used for plastic sorting right now, currently in the MRFs. Mid-infrared is something that we're starting to pay attention more in the research area. Black plastics are something that we can begin to differentiate using a mid-infrared detector. Raman spectroscopy is another infrared technology. X-ray technology, X-ray fluorescence and transmission. There are two different types of detectors. They're typically best used for single item analysis. If we want to detect the different alloys I mean, for example, looking at a piece of scrap siding versus an aluminum can, it'll be able to tell what type of alloy it is. For the infrared spectrometry that we talked about up here, it works well for plastics that doesn't have a whole lot of application for metals right now. The X-ray fluorescence, again, works well for one item at a time, but for looking at a full bed or a full belt of materials, you can do it. There are a few companies that do it, but it's not widespread yet. It's still, in my opinion, on the developing end. The last one is laser-induced breakdown spectroscopy. Essentially, you take whatever material it is and you shoot it with a laser, and whatever gets shot with a laser, it gets blasted to smithereens, for a better lack of a better word. Then we measure the spectroscopy or the spectra that's coming off of the smithereen particles, if those are real, and you can detect what type of material it is. Works well for plastics, for biomass, for metals as well. Now, the AI-powered or the machine learning sorters, this is where it becomes interesting and powerful. These are sensors that can be trained, and we can train them not just to recognize materials, but also to make complex decisions. If I have a residue line or any kind of line, if you look on the picture on the right, there's all sorts of materials on there. I can tell it that I need to collect aluminum first, so make aluminum priority. My second priority is paper, and then my third priority would be PET. And it will organize its decision making, because a lot of times there's going to be more material on a belt than it can So it can't always process everything, but I can make it target the most valuable things. Right now, most of the sensors on these AI-powered units are visible light oriented. They use high-resolution cameras and high-speed cameras to capture pictures of things, and you train the system to identify features of objects that it can recognize. So, I mean, if you take yourself, for example, if I see a grass that is green and I see that a tree that is green, I can recognize characteristics that help me differentiate the difference between grass and trees. This application, it'll teach it to recognize characteristics of aluminum cans versus steel cans, or aluminum cans versus bottles, so that it can use the visual cues that it has to do this. One very interesting application, I'm needing to look to see how much time I have. One interesting application this has been used for is using a visual camera to detect alloys of aluminum. Very high fidelity sorting that can be done with this, not because it can do a chemical analysis, but because it can recognize characteristics of the material. So with that, the technology is available to improve our performance. Prices range starting on the very low end for a eddy current sorter of $50K to $200,000 for some of your robotic or automated sorters and on up. But the technology is available, and it is working well. It's a great opportunity here. Back to you, Scott.
All right, thanks, Jeff. It was interesting to hear about all the new technology, and we have this thing, the eddy current, that Corinne talked about being super effective, but that there's other things like robots that can be super effective too, and can find other materials. So with that, we'll go to our first MRF operator here. So I'll turn it over to John Hansen to talk about his experience with the robots at his facility in Sarasota.
Thanks, Scott. Good afternoon, everybody. What I'd like to do is just touch on three different things today in my time that I have. One would be what we're currently working on to increase our UBC capture rate. Two, what we already have in place at our facility. And then three, the challenges of doing some of these upgrades in order to capture more containers as one, reduce labor as two. So there's some other things that go along in this decision-making process. But so I'll start out with the first one, what we're currently working on. We actually run optical scanners on our fiber lines for those flattened cans that everybody's been talking about that carry up onto the 2D line. So we use optical to sort them, and it is not, we have an okay capture rate with it, but with the moisture contents changing on a daily basis down here, when you try to get too aggressive with your opticals to try to eject aluminum cans, you tend to shoot some extra paper. We don't want to do that. So we've been fighting back and forth with that. And so we are now adding some metal detection into our optical scanners in order to hopefully increase the consistency and capture just about, obviously we'd like 100%, but that's kind of a dream. So from there, that's what we're currently working on a project now. So, but what we have done in this past year is we have added 14 robots to our facility. We added the robots initially to cover labor cost, increase product quality, and things of that nature. But we also understood that when we did do this, that at the end of the day, we were going to capture more UBCs and high value items. So out of the 14 robotic arms that we have put in place, they're spread across our plant through quality control on our fiber lines and quality control on our container lines. So, but out of the 14 that we put in place, 13 of them actually target UBCs. So they're in a quality control situation. If a UBC makes it to the PET line, it'll pick that aluminum can off there. Any of the plastic lines, it does all that. Paper lines, same way. If it makes it past our optical scanners, we have the ability to capture those with the robots there as well. The 14th arm that we have in there is actually our quality control arm for our UBC line. So our UBCs are taken out at the end of our container line. So we eject all the other plastics, everything else off the line. and then it hits an eddy current. And we do that because we want to have as little material on the belt so you don't get cross-contamination with the magnetic field. If there's a piece of paper in the way, it's going to carry the piece of paper over, then you get contamination. So we do this, the UBCs come off the eddy current and they go up into that last 14th robot where the quality control is there. And as everybody understands, these high value UBCs have to be super clean. So we use the robot to pick any residue, any paper that might have gone up there, as well as off-spec aluminum. So your aerosol cans, things of that nature, they get picked as well at that location. And we actually do have one more person, just because of with COVID, we have noticed the rise in the amount of aluminum cans. So we've had to put an extra person up there just because of the sheer volume. Our robots are picking, that robot on the UBC line is picking between 70, 80 picks a minute. So it flies, it goes crazy fast. So then we have at the end of our line, something else that was discussed earlier. We have a robot on our residue line. So as Jeff was talking about, there's high value items at the end of that line that are still in your stream. One, we have the robot there for number one to pick aseptic cartons. We work with the Carton Council, so it picks aseptic cartons there. The second pick that robot does, we prioritize it for UBCs, then HDP natural, then PET. So you can, as Jeff said, you can set that up in your robotic system and prioritize things, which make it quite good and quite effective at capturing the high value materials there. So I guess the last thing, the number three that I wanted to discuss are the challenges, because everybody talks about putting this equipment in and doing it. And, you know, we put in 14 robots. We think we're pretty good at it now, but it is a major challenge to do these types of things. And it takes a lot of planning. You don't order a robot today and AMP says we're going to deliver it to you in 6 months, and you wait for it to show up at your door and then you put it in. There's many weekends prior to this where you need to be adding, one, you need to add air to that location. Two, you need to add power to that location. Three, you need to add data to that location. Four, you need to add infrastructure to that location. So when you do get your robot finally and you're flying it into place, it flies right into place, sets down, bolts down, and then you can put everything together. So we did about 3 robots a weekend as we were installing these. So downtime in a MRF is, no one wants downtime in a MRF, and it's always really difficult to plan these types of things. So what we did is we took a Friday afternoon and we had everything else done up to that point in time. Friday afternoon, we'd give the plant to AMP. AMP would come in with their crew, along with our crew side by side. We'd fly the units in and start assembling power to them, air to them, everything else. And by Monday morning, our game plan was to be back up and running on a Monday morning with the robots in full working order. And we had quite a bit of success with this. We did have a couple of things that were out of everybody's control on some shipping items, but we were able to accomplish it. One of the other things that is difficult in these types of situations is your space and space requirements, whether you have headroom, height, whether you can use the robot to drop material directly into an existing gravity bin that can go to a baler, or whether you have to convey it. So there's a lot of different things that go into these projects, and you just have to plan really hard and work through those issues before the robot shows up. So with that, I'll turn it back to you, Scott.
Okay, thanks, John. You know, it's interesting to hear about that it's not just one robot. You've got quite a number of robots that are quality controlling for UBCs, and you know, kind of easier said than done to install these things. Sounds like it takes a lot of planning and thought, but I'm happy to hear that you've had some success with it. So now I want to bring in Kate Davenport with Eureka Recycling to talk about not so much robots, but more the eddy current separators and the fact that she has 2 in her operation. I can talk about her experience with that. So go ahead, Kate.
Thanks, Scott. I'm going to share my screen here. I'm Kate Davenport, the co-president of Eureka Recycling. We are a nonprofit recycler based in the Twin Cities in Minnesota, and we approach recycling from a zero waste perspective or a mission perspective. So our mission is to demonstrate that waste is preventable, not inevitable, and we really believe that we can get to zero. We've designed waste into the system in the last 150 years. We can design it out of the system. We started in 2002, and so we run a collections and processing business unit. The proceeds from that feed back into our nonprofit, where we do advocacy, research, and education around how do we get to zero waste, and how does zero waste address climate change, local economic development, and environmental justice issues. We have the municipal contracts for the city of Minneapolis and St. Paul, as well as several suburbs and other independent haulers in the marketplace, and we process a little over 100,000 tons per year at our MRF. We do about $14 million a year in revenue. And so we really approach our material recovery facility as a zero waste lab, again, really trying to understand how recycling and a MRF helps us address these bigger issues. The end goal is not to recycle. The end goal is that recycling supports addressing climate change, local economic development, and environmental justice issues. So I'll talk a little bit about how our facility works and the use of the two eddy currents. So this is a diagram of our material recovery facility. For those of you that aren't familiar with a MRF, essentially what a MRF is doing is taking the pile of material that you put in your cart where you've mixed paper and glass and aluminum and plastic, and we're unscrambling the egg. And so in 2016, we were looking at upgrading our facility. We were looking at upgrading it because we were about to get about 20,000 more tons into the facility. So we needed to create some efficiencies and figure out some ways to run more tons per hour. We also at that time, and Corinne and other folks have noted this, we're realizing that there was a lot of PET and aluminum going into our paper for exactly the same reason they're noting, that those materials get compacted in the collection process and then flatten and end up with the paper. And so we were both doing an upgrade again for efficiencies and running more tons per hour, as well as better sorting our material. And so we originally, our eddy current, original eddy current before the upgrade here is number 13, was at the end of our line, which means it's the last thing to sort after all of the other containers are sorted. And so in the design of the upgrade, and I would just highlight too that these upgrades decisions and equipment decisions are not overnight. This takes months of planning and looking at what the best schematic is, evaluating vendors, and understanding what the return on investment is, because you're talking often about millions of dollars. We decided to install two eddy currents. Now, part of the reason we decided to do this was that we were increasing our tons per hour, and that our current eddy current at the end here, number 13, was just not large enough to deal with that increased tons per hour. We went from 35 to 45 tons per hour. So what we did was here, after the OCC screen number 3, which sorts out the cardboard, we put in what's called a scalping screen. So it's a screen that's set at about 5 to 6 inches, and this is what's capturing the hockey pucks, as well as small paper. Because we realized that that's why the aluminum was going into our paper. So let's try to screen that out with the small paper. And then we can further address that small material with the hockey pucks and small pieces of paper in a ballistic here. The other material runs over our polishing screens and another ballistic. We have 2 ballistics actually. So we installed a scalping screen and a second ballistic to help get out that smaller compacted material in the paper. So you've got aluminum running through 6, 7, 8, as well as running through just 8. Then the material comes into our main sort house. 10 and 9 here are our fiber lines. 9 is our big fiber line. 10 is our small fiber line where the small hockey pucks are. And we have sorters that can then manually pull out those small hockey pucks if they weren't pulled out by the ballistic. So we've got several stages there. Then we have number 11 here is our container line where we're doing quality control to get the paper out. And then it runs through a magnet, and then our first eddy current is right here. And it's a bigger eddy current than the original eddy current that we had. And then the material runs through an optic manual sorting, and then a second eddy current. And so I think my highlight is just that that system has worked effectively. We're essentially pulling out aluminum at the beginning and the end of the container line. And we needed that scalping screen and that ballistic to get it into the right streams in the first place to address the 2-dimensional versus 3-dimensional. So it's been quite effective for us, and it again helped us get to a different efficiency level and run more tons per hour, which is where a lot of the return on the investment was. Prior to this, our estimates were that aluminum in our fiber was ranged between 3 to 5% of our aluminum was being lost in our fiber. We are now down below 2% of aluminum in our fiber. So again, it's not perfect, but we cut that loss in half. And now we're continuing to look at how do we continue to get that aluminum and PET bottles out of the fiber. We are looking at robotics for that. We think there may be some opportunity there. We'll be continuing to look at that. But this system upgrade was really effective again in getting more of that aluminum out. I do just want to highlight that the return on investment was really contingent on getting that aluminum out, but also the efficiency that we created to make that all run together. The other thing I just wanted to highlight before handing it over is that I think it's really important when you're looking at a MRF and you're looking at equipment that you look at seasonality issues. So we see aluminum as a percentage of our stream fluctuate a lot. We see a lot more aluminum in the summer. And so when you're looking and analyzing your stream to understand how much you're losing, it's really important to not just look at one point in time, but to look at it across seasons. Because if you do your analysis in January, you may have different numbers and a different return on investment than if you look at it in July. And so you really need to look at that whole picture to understand the type of equipment that you need, and again, the return on investment. The last thing I said is because of COVID, I saw some questions about this. We've seen about a 10% increase in tons in general coming from our residential streams. We've seen a significant increase in aluminum. So our aluminum percentage prior to COVID was about 1.5% of our stream by tons. After COVID, it's above 2%. And so that also is playing into our decisions. There's some challenges there to understand if that's a permanent shift or not. So I just wanted to highlight too, I saw some questions about that. And I will pass it back over.
Well, I'm impressed that you were somehow able to monitor the questions as you were presenting. So no, it's interesting to hear about the success you've seen with less cans going to the fiber, and you talk about how long this process takes. I mean, my hope is that tomorrow, after everybody sees this webinar, it's going to be eddy currents everywhere, but I guess we'll have to wait a little bit for that to happen. So thanks for sharing your perspective. I will say, Kate, before you leave, we had a question come in from Susan. She was asking if you could repeat the pre-eddy current and post-eddy current capture rates. She couldn't hear, and maybe others didn't hear it either. Maybe she's talking about the difference with the fiber, but I don't know if you mentioned
so prior to the installation of the scalping screen ballistic and second eddy current, we were seeing that about 5% of our paper was aluminum, and that was cut in half.
That's a big deal.
So,
okay.
Yeah, I can't do the math in my head right as we talk about how that impacted our overall aluminum capture rate, but it was pretty significant.
Yeah, no, sounds good. Thanks so much, Kate. And with that, I will turn it over to John, who's going to take us home and talk a bit about investor perspectives on aluminum can capture, given its high value.
Thanks, Scott, and I appreciate you and CMI for inviting us to participate. And I think I can appreciate your masterful construction of this discussion, because all the prior speakers coming from kind of the consulting perspective, the MRF perspective, and then really kind of the research perspective, looking deeply at these emerging technologies is going to make my job pretty easy here. So I do want to give a little bit of perspective on how we look at upgrades like those for improving the capture of UBCs, not only at MRFs, but upstream of that. And so just a little quick level setting on who we are at Closed Loop Partners. So we're an asset management firm, an investment firm that focuses exclusively on the circular economy. And so an easy way to kind of think about us is in two different buckets. We have our investment arm, then we have the Center for Circular Economy. Again, everything is focused on the concept and the uplift of what we call the circular economy. And so on our investment side, we make investments in a variety of ways to try to increase the capture of various materials value. We do that through a private equity and a growth equity arm. We have a project finance arm, and I'm going to highlight what that means here on the next slide. And then we also have a venture capital firm in which we're investing in early stage companies that are innovating around either material science, logistics, supply chain transparency, and also different technologies to help recover materials. So AMP Robotics being one of our venture firms investments. And then our Center for Circular Economy focuses on large kind of intractable pre-competitive collaboration efforts. So imagine multiple companies that have a shared problem come together pre-competitively to try to solve for a material challenge, a recovery challenge, et cetera. And we've got different examples of that. And then we also have on a kind of a bespoke basis some advisory services and also kind of our R&D arm as well. And so in digging into our infrastructure fund, within this fund, we are making investments to try to improve outcomes all along the materials value chain, the supply chain. And we do this in a variety of ways and a variety of points, nodes along the network. And so on this map, I think the thing to focus on, what I think is particularly relevant for this discussion here, is our investments in collection and in sortation. So those are denoted by a purple and a blue mark. We've made about 25 investments to date. We're fortunate to note that Kate and her group at Eureka is one of our proud portfolio organizations in which we've invested. And really, ultimately, the goal that we try to reach with these investments is really twofold. Number one, are we creating impact? And we have a pretty deep series of metrics that we use to evaluate opportunities and also to track progress and outcomes over time. And then, of course, as an investment firm, we want the investments to pay off, which we do by closely vetting projects and also providing support on an ongoing basis. And so we can see just based on the coloration, we have a lot of interventions that we've helped to finance, both in terms of the collection side of things, so getting more materials into the recovery chain, and then at the sortation side of things, trying to uplift outcomes, create better bales, and allow more throughput at our MRFs. I want to highlight a point, and Jeffrey had touched a little bit on this with some of his overview of the data, the state of things in the US. And I think what I want to highlight, one of the things that we do are we create quite robust and extensive granular data sets, which can help support our investments. And so what I'm showing here is a detailed outcome based on models that I've built out, looking at what is going to disposal. So what are we missing? And Corinne did a great job of highlighting what she and the GBB team did in examining, once materials get to the MRF, what is it that we're missing? But I think when we step back, the numbers become even more dramatic when we consider what isn't making it into the recovery stream in the first place. I've put a red box around the amount of metals going to disposal. About 13 million metric tons based on the most recent data we have went to disposal, and therefore we're unrecovered. And I'll tell you that of that, about 1 million to 1.2 million tons are comprised of aluminum UBCs. And so I think, as investment folks, we think of this in terms of not only tons, but dollars. And so when we look at 1.2 million tons of material that's missed at current commodity values, that's $1 billion opportunity that's being missed. And so I think the report in this webinar are pretty timely, so that we can kind of coalesce all of these challenges. So knowing what it is that we're missing, but also the promise about the different technologies. John did a great job of highlighting how robotic deployment at his facility has been able to uplift their outcomes and really create clean bales. And so again, I think the punchline here is that we've got a lot of work to do, and the good news is that we have the tools and the techniques that are available to seize this opportunity, not only at the MRF in getting the materials out once they've been delivered, but also on the collection side of things, on a messaging side of things, education side of things, access side of things, trying to up the access and increase the sophistication of those that are generating materials, so that we get that valuable material into the stream and improve the overall system uplift. And so I think it's all fairly intuitive, I think, to most people on this call, how exactly do we capture this opportunity? And so so I think kind of driving things home here, we have the multitude of opportunities to try to drive additional collection. And so trying to get at these sort of collection deserts, if you will, to try to improve capture of all recyclables, inclusive of UBCs. So that we have the chance to disaggregate that mixed mass of valuable commodities and try to create these better outcomes. And then at the MRF side of things, and we got to touch a little bit earlier with some of the speakers on kind of the complexity and the nuance. And so from our perspective, when we consider a potential project, and I should note that kind of where we come into play is when a MRF, a community makes a decision about how they're going to move forward with either improving collections or improving the sortation at their MRF, they would come to us and propose their project through our infrastructure fund. We would evaluate that, make sure it meets with our standards and gets through our diligence process. But once that happens, then we would move forward. And oftentimes, one of these tricky things, there's usually never one, kind of flat out right answer. MRFs come in all shapes and sizes, different ages, different levels of sophistication, different desired levels of sophistication by the operators or by the owners. And so we take all of these things into account when examining an opportunity. And again, as our speakers have so thoughtfully assembled, there's a lot of different ways we can kind of get at this in terms of where are we positioning robotics, where are we positioning eddy currents, how might we contemplate some perhaps less proven technologies and make sure that those work and then deploy those at scale. So we're really technology agnostic when it comes to that perspective. We let kind of the design experts do their thing. But we intake the opportunity and a review, and that's kind of how we work. And so we absolutely share the sentiment that improvements across the system are needed, and that's what we work toward. And often, in terms of investments that we might make, an aluminum capture improvement may be just one element of a much larger retrofit or perhaps even a greenfield site. And so. So really, we try to consider the spectrum of opportunity, inclusive of kind of idiosyncratic material-specific improvements, and then also, and an example of that, we have a separate fund that's kind of a sister fund to our investment, our infrastructure fund that is focused exclusively on PET capture and recovery. And so I'm happy to speak further about that. But ultimately, what it boils down to, how can we put in the right tools, technologies, and techniques to get an acceptable return on our investment and create meaningful impact across the system. So, so with that said, I've got my contact info here. I'm sure these slides are going to be shared to the distribution list. Happy to answer any questions that come through now or subsequent to this call. So again, Scott, appreciate you and CMI for looping us into this discussion, and look forward to some lively questions here.
No, thanks for for joining, John, and I appreciate sort of your take-home message. There's a significant opportunity here, and we have the technology. We just got to figure out how to scale it, get it out there. And we heard from the MRF operators how they've done it, but it does take some time. And I want to invite everyone to turn on their video if they like. This Q&A part will now be for anyone to join in. We've got about 6 minutes here. I guess I want to start with one of the question that kept popping up as I was monitoring the Q&A box was about plastic shrink sleeve labels, and that those could be a potential for missortation. So if anyone wants to chime in on that, that'd be great. If that's indeed something that MRFs are seeing as an issue in terms of being able to properly sort the cans, but also as we think to the larger problem of why these cans are being missorted and the opportunity to properly sort them, how can we better engage MRFs so that they do consider this as a prime investment opportunity as they look to retool and modernize their MRFs?
And I can, the shrink sleeve label issue, sure. I see John Powell smiling a little bit because I think we've talked about this, but we have definitely seen those. I can't give you a percentage off the top of my head about how much, but oftentimes those sleeves are some kind of plastic, obviously, and so there can be a challenge where the optical sorter that we use for PET reads the can as PET, and then it becomes a contaminant in our PET. And I think that's really not a MRF issue. That goes upstream to design, and folks that are designing aluminum can packaging really needing to understand the impact of their design, because that creates additional cost for the MRF, and then we're either having to quality control that or it's contaminating the PET bale, for example. And the aluminum folks don't necessarily want that PET wrapper or plastic wrapper either. We have also seen on the marketplace, I have in my office like all the crazy stuff we find on the line. We have what looks like an aluminum can. It's a top and a bottom, and the body is PET, which you've just taken two highly recyclable materials and made it non-recyclable. You've just, if it goes in the aluminum, that's a contaminant and vice versa. So there is a responsibility for folks that are using aluminum cans as a packaging type to think about their design. It can't just fall on the MRF to figure out what to do with it.
No, that makes sense, Kate. And I wonder if you or John, maybe just because you operate MRFs, how can we better get this message out to MRF operators?
Well, I'll piggyback on something that Kate said, and this is, sometimes this is one of those, rock and a hard place type of things. So, the reason that we see these labels, and I can't remember how the question characterized it, but usually it's either a vinyl or it's a PET. So there's like a shrink wrap or there's a sticker. But if you consider a microbrew, which are normally making these things, there's a minimum order size that they need to that they need to reach in order to get the actual printing done on the can. And so a lower cost option is to get a generic aluminum can with no writing on it, then slap a label on it. And so I wholeheartedly share kind of the design consideration, but I don't have a good answer for that, I guess. At some level, a microbrew wants to sell product, but they can't order, a million cans because they're not that big. They don't manufacture that much. But I think, Scott, to your question on the larger, larger issue of how do we get the message out? I think I think there are certain kind of drumbeat messages that have to continue being out there. And I am not a MRF operator. I will let John and Kate correct me if I'm off base, but often there are many, many things that an owner operator is juggling at any given time. And it can be a little challenging to assume that, any one topic that we might be talking about here floats to the top. I mean, there's, keeping the facility running with enough personnel, and there's babysitting the robots. We have a whole new thing, right? Or I shouldn't say babysitting, but at least making sure everything's working effectively. And so I think it's just one of those things we have to continue including in, outbound messaging. And I think a lot of it, what we find is, asking the right questions to the right parts of the value chain to understand what the real challenges are. So we've heard there may be some problems with recovering it at the facility, but then when we talk about why are we doing all of this in the first place, the reclamation or the reprocessing, how is it affecting downstream? So not a terribly satisfying answer, I suppose, but.
No, it's good. And, I know we only have like a minute left here. Does anyone else have any parting words before I, say goodbye to everybody that they want to make sure to get into the audience here?
Yeah, Scott, I would just say real quickly on the coated aluminum UBCs, we do capture them. They get ejected in PET, and we capture them with a robot. And it wasn't something that we bought the robot because that's what we were going to capture with it because we knew they were coming there. It's just been one of the benefits of adding that. So,
no, I appreciate that, and I know we're basically at time, so I just want to thank all the presenters for sharing their insights with the whole group here. We do have the whole report that Corinne and her team put together, and that's at cancentral.com/cans drive recycling. So I encourage you to check that out. And it doesn't end here. The can industry is committed to increasing its leading recycling rate to get it to new heights. And certainly one of the ways we want to do that is to get more aluminum can capture equipment in MRFs. So we're going to figure out how to build out this report. And I think this was a good first step to raise that awareness. And we want to take other steps. So anyone who's listening that wants to collaborate with us or other people, I'm sure, that presented, you can reach out to us. And we thank you for joining us. We'll post this whole webinar on that site that I just mentioned, cancentral.com/cans drive recycling. So thanks for joining us, and talk again soon.